So forget the infinity and forget...
Oh, that's nice. So here I forgot.
This is about phone calls. I think I've never given you a question about phone calls.
Nope.
Okay, so I'll start with a problem, which is it's often called the gossip problem. So you have n people, and each one, and it's finite, we're definitely finite, and each one knows a secret or a fact.
Mm-hmm.
So n different facts, each person knows one. And they make some phone calls together. And in a phone call, each person tells the other person everything they know.
Okay.
It makes sense?
Mm-hmm.
And you want, so maybe, A phones B, then A phones C, then B phones C, then A phones C again, who knows what it is. And you want to do it in such a way that at the end of all time, everyone knows everything.
Mm-hmm.
Does that make sense? And the question is, how few calls do you need?
We understand, but we can already tell that's going to be a wonderfully annoying question.
Yeah. So here's an example. Let's
Sure.
There's 5 people. I want to solve it as follows. I'll do an example that works. I'm going to basically make everyone tell their secrets to A.
Yeah.
So A is everything, and then A tells everyone back again.
Yep.
Makes sense? So first let's start with E phones A, then D phones A. At this time, A is everything, right? So A is a tick.
Yeah.
Now, of course, E doesn't know everything. E knows A, but nothing else. So now we'll reverse it.
Mm-hmm.
Except I don't need to repeat A, B, do I? B knows everything as well now. So now I'll go again, C, A, D, A, B, A. It makes sense?
Yep.
Yeah. So that obviously works, right?
Yeah.
So you're going via one person. So how many calls is that? If there are n people, then here it was, I guess, n minus 1 calls, right? Everyone phones A in any order. And then A phones everyone, except A doesn't phone the last person again. So it's actually n minus 1 and n minus 2. Does that make sense?
Mm-hmm.
So it's 2n minus 3. So you can do it in 2n minus 3.
Mm-hmm.
The question is, can you do it in less?
Huh. We don't have a lower upper
I'll
bound?
keep talking for a bit and I'll get to it.
Sure.
So, for 3 people, this would say you can do it in 3 calls, right? 2n minus 3. You clearly can't do it in 2 calls because the first call may as well be AB, and they're all calls equal. And after that phone call, I guess somebody calls C. Doesn't matter who, right? So it's AC.
Mm.
But then B doesn't know everything.
Mm.
Agreed?
Yep.
So 2 calls is not enough. So for n is 3, the answer is 2 minus 3.
Yeah.
And also, if you have a solution for n people, here's an obvious way to solve n plus 1. May not be the best. Take your n people, here's your new stranger, or your extra person. Here's what you do. This person phones that person. Do you agree at that time, these people between them know everything?
Mm-hmm.
Then do the solution for n.
Yeah.
At the end, one of them phones him and tells them.
Sure.
So it goes up by most 2 every time. It makes sense?
Mm-hmm.
So if I told you, for example, say for 5, I did 5 in 7 calls, right? If I could do 5 in less, like 6 calls, I could therefore also do 6 in less, because I had 2 each time. Makes any sense? So again, here I did 7 in, no, I did 5 in 7 calls.
Mm-hmm.
Right? And simply this, we also can do 6 in 9 calls, and 7 in 12 calls, plus the 2n minus 3 done.
Sure.
Okay. Now suppose that for one of those I could improve, even by 1. Suppose I told you, here's an amazing way I can actually do 6 in 8 calls. Suppose I could do that, if I could do that. Then by this method here, I would then also do 7 in...
11. 11.
11. So if I could do 6 in 8, I could then do 7 in 10. Does that make sense?
Yes.
So I would take the 6 clever solution, add one person twice.
Yeah.
So go at most 2 each time.
Mm-hmm.
Now, the answer is not to turn minus 3, because there's a pretty thing you do for n is 4. So for n is 4, this proof would say DA, CA, BA, CA, DA.
Yeah.
5 calls. You can do 4 in one pretty picture. You draw them in a square, and first those calls happen. So in each column, you know the entire column, then these calls happen afterwards. Make sense?
Mm-hmm.
So after the first 2 calls, you know your whole column's information. So in any cross call, you know both calls are everything. And notice that is 4, not 5.
Yes.
Okay, so that does 2n minus 4. And the question is to prove that's the right answer.
Huh.
So the answer is 2n minus 4. Okay, sorry, if n is 3, it's some silly number like 2n minus 3. The question is to show that it's always 2n minus 4.
Okay.
Again, achieving that's very easy. You take the solution for 4 and do this again and again and again.
Mm. Yeah.
But how do you know you can't do something clever and get 2n minus 5 or
Nobody
1
knows.
or something?
So nobody knows whether there is another clever trick that could bring it
This
in.
is a question I know the answer to.
Okay, good.
This is the exercise.
Okay, gotcha.
I'm not saying it's an easy exercise. But
No,
it's an
no,
exercise,
good. We
okay?
start there.
And now I'll get to the question which isn't there.
Okay.
So this time, again we have n people, they each have a secret, they make phone calls, you've got to have few, you want to find a few phone calls that everything. It's like that, except this time, for each pair of people, if they're going to make a phone call, it's a fixed time that the enemy's given to us. So we draw an example already. Here's an example. So here are 4 people, and I'm going to, there's 6 possible calls in the universe, right? I'm going to tell you what time they're going to happen if they're happening. So no call happens twice ever. That's not allowed. So maybe I'll go 1, 2, 3, 4, 5, 6. Does it make sense? So what that means is you've got to select some phone calls, but the order isn't your choice. They go in time. This was Monday, Tuesday, Wednesday, Thursday, Friday, Wednesday. Okay? And the task is, when you're given the numbering, finding a few phone calls where everyone knows everything.
Okay.
So in this particular example, for example, you couldn't say, oh, columns and rows. Because if you just look at those 4 calls, it's this, then that, and that, isn't it? And if you think about it, if I do this, then this person doesn't know everything. Because this person never learned that person's information. In fact, I picked those 4. Does that make sense?
Yeah.
So again, it's your choice to pick which calls you're going to pick. So in that problem, in the first problem, you were free to choose the phone calls and what order they happen. You were like God. In this one, your opponent, God, or your opponent, devil, so this is a devil, your opponent has told you some unpleasant ordering.
Okay.
You need to pick some things. And the question is it always doable in 2n minus 3 calls? Or even in 10n, is it linear? Of course I can do it. Is this notation for
Yeah, we say k and n comma 2. We would say k and then a bracket, like k and then n bracket n comma 2.
like this?
Yes.
Okay. You can certainly do this many things. Here's what you say. You say, I allow all phone calls. And
Yeah.
obviously, everyone knows everything, right? Because person number 5 knows person 17's information because they talk directly at some point. It makes sense?
Yes.
That's wrong. That's n squared. That's where the 2 or something. That's terrible. It's a lot of calls.
Yeah.
You want to have only linearly many calls.
Okay.
So it could be 2n minus. It's not 2n minus 4. You can generalize this. So another nice exercise for you guys is to find a devil's way of numbering things for n. so that you can't do 20 minus 4.
Okay.
But the question is, maybe you want to do 20 minus 3. And if you can't, but it's not even only if you want to do 10. It's not like, so like in this question over here, I initially said, look, you can always add those 2 each time.
Mm-hmm.
So of course, I can do like 20 minus 3, something like that.
Sure.
Then we thought we did 20 minus 4, and then your exercise is that's best. Here, it's not obviously you do it in 10n.
Okay. So basically,
if you claim 10n, you'd be saying the following. The following fact, you'd say, whenever I have endpoints, and whenever I'm given some unknown ordering of those edges, like time slots, I can always pick out 10n of the n squared edges in such a way that those phone calls work.
okay.
And maybe it's 20 minus 3.
All right.
So here's a question. You have 10 people, and any two can phone each other, but only a certain time,
Mm-hmm.
which is the devil's chosen fuzz. Right?
And
So I and J can correspond, but only at a certain time.
Okay.
And the question is, can you pick out of all of the 10 choose 2 phone calls,
Mm-hmm.
can you pick out 17 of them,
Mm-hmm.
2 minus 3, so that if just those calls happen, of course, in their order,
Sure, I got it. So basically, we have every possible call have to happen in some sequence,
yeah.
and we have to decide which ones we actually make.
Yes.
Gotcha.
Yes.
Gotcha.
The difference was in the original problem with 2 minus 4, you pick the call and you pick the times.
Right.
It's up to you to make them everything.
Okay.
Which
Got it.
here, once you said what the calls are, the times aren't fixed. The times are not your choice, they're fixed.
And it's not even known if this is a linear.
No, literally.
That's odd. I can see why, but it's still strange. So basically,
It's very hard to get a hand on every possible. There are lots of ways to order.
Yeah, we'll see.
That's why it seems hard to understand. Nice answer. There should be some nice answer.
Yeah.
There definitely should be an answer to that.
Huh.
And this is your first exercise is to do.
Yes.
And I suspect the exercise won't help with that thing.
Probably.
Because the exercise only is showing you need these 10 minus 4, and you can't even do 10 minus 4 here, it's 10 minus 3. So I suspect the exercise is not useful for that, but it's a fun exercise anyway.
Sure.
Let's do 10 minus 4.
Interesting. Fantastic.
Okay, so different permutations. But do keep thinking about permutations. So some of you in your final year of school, you can